All right, help me out, guys. 5-number summary for 2000. What is our minimum? 6. Minimum is approximately 6. What about Q1? 14. Median? 20. Q3? 22.5. I like it. When you follow it down to the line, it's falling right in between 22 and 23. So I would go with 22.5 as well. And the maximum? Let's look. I would take 26.5. I would take 27. It's really close. So if you called that exactly 27, I would count that as correct. If you called it 26.5, I'm fine with that. I think now that I drew the line down to the bottom, I'm going to split the difference and call that 26.75. Again, if it's falling in between values, make your best approximation of what that is. What about 2010? Minimum? 8. Q1? 11. Median? 17. Q3? 20. And maximum? 28. Beautiful. One of the things I want to caution you guys on, just depending on the layout of the page, sometimes they're going to have it in a row and it's all in order. Sometimes they're going to have it in a column and it's all in order. And sometimes they've got it in 2 columns. And if that's the case, sometimes they have you like going back and forth, and just make sure you read what it is that you're supposed to be writing there. Yes, sir.
So like for 2000 Q3, I put 42.8.
That'd be fine. Yeah. If you're having to do those approximations because it's not falling exactly on a whole number, as long as it seems reasonably close, we're good. If you told me for Q3 on 2000 that was 21, no, that's too far away. All right. Rest of class time today is devoted to questions you guys have about the review. Does anybody need another copy of the review?
I do.
There you go. What would you guys like to look at on the review? Number 2. Sounds good. All right. We're going to open up a safe. 5 numbers need to be entered on a keypad. The keypad contains the numbers 0 through 9. So as we're looking at this keypad, how many options do we have when we go to push a button? 10 options. When you go to open a safe and you enter a code in, does it matter which order you enter the numbers? Yes. So we would consider this to be a combination or a permutation? Permutation. Why? Yes. This is a permutation. Because the order the numbers are entered in matters. All right, guys, side conversations need to die. How many possible ways can you enter 5 numbers to open the safe? So if I wanted to put my dad's birthday in as the safe code, he was born November 8th, 1958. So if I wanted to do 11/8/58, could I choose that? So are repeating numbers okay if I have 11/8/58? Yeah. So with that in mind, we're going to enter 5 numbers here. For the first number, I have how many options for this first digit? 10. How many options do I have for the second digit? Still 10. I could do 11. I could do 1 and then 1 again. Repeats are okay. So I have not eliminated any of my options here. How many options do I have for the third number? Still 10. For the fourth number? 10. And for the fifth number? 10. What am I going to do with all those 10s? Multiply them. How many times are we multiplying 10 by itself? 5 times. So 10 to the 5th power. That's going to be a 1 with 5 zeros after it. 1, 2, 3, 4, 5. You are welcome to pop that into the calculator. But 10 to different exponents, that exponent tells you how many zeros there are. All right. If no numbers are repeated, then how many ways are possible to open the safe? So I'm still going to have to enter 5 numbers. Down here in part C, could I use my dad's birthday? 11/8/58? No. Why not? Yeah. No numbers are allowed to repeat here. So how many options do I have for the first number? 10. How many options do I have for the second number? 9, because once I use up a number here, I'm not allowed to repeat it anywhere else. How many options for the third number? 8. How many options for the fourth number? 7. And how many options for the fifth number? 6. What are we doing with all those? Multiplying them. You guys sound so excited about this. And that comes out to be what? 30,240. Not allowing repeating numbers really cuts down on how many codes are possible. Part D is asking me about this in part C. I want all the different ways that I could represent this same idea. All the different ways that I can get to that final answer. Does anybody remember what we call the exclamation point? It's at the beginning part of your notes, starts with an F. What do we call the exclamation point? Close, but no. What do we call the exclamation point? Fundamental counting principle, that's what we used here. Factorial. This is a factorial. What does factorial mean? Like, how do you actually calculate something when it's got 10 and then an exclamation point after it? Not 0, but close. You go down till you get to 1. So we would do 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all the way down to 1. Is that what we did up here? All the way down to 1? No. We did 10 times 9 times 8 times 7 times 6, and then we stopped there. Does this one stop there? This one would come out with a different answer then, because you're multiplying by more numbers. So that is not the same. So no. What about the next one over? Here I have 5 with an exclamation point. So I have factorial again. How would I calculate this one? 5 times 4 times 3 times 2 times 1. Is that what I did up above? No. I did multiply a bunch of things together, but it wasn't those numbers. Look at this third one here. What do they have going on there? I have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 in the numerator of a fraction. What about the denominator of the fraction? 5 times 4 times 3 times 2 times 1. Would any of those things cancel since I've got it set up as a fraction? 5, 4, 3, 2, and 1 will all cancel. And so I'm left with this. Is that what I did up here? So this right here would be a correct representation of what I did up above. What about the last one in the top row? Is that a correct mathematical representation of what I did up above? Yes. Let's hop down to the bottom row, far left. 5 times 4 times 3 times 2 times 1. Is that a correct representation? Nope. So not there. What does this next one mean? What does that P mean? Permutation. Did we say this was a permutation or a combination? We said it was a permutation. How many things did we have to pick from originally? 10. How many did we choose for the code? Is this a correct way to put that in your calculator? Yes. If you put this in your calculator, you get that number back out. So this is a correct representation. What does the C mean in the next one over? Combination. Is this an example of a combination? No. The order of the numbers matters, so this is not a combination. What about that very last one? Is that the same? 5p10? Why not? We didn't start with 5 options. We started with 10 options. I can't start with 5 things and choose 10 of them. That's what this notation is saying. Like, I have 5 students in my room and I'm going to take 10 people outside. Can't do that. All right, what else would you guys like to see off the review? Number 4. All right. Any that you guys want to see, I'm happy to go over. Mr. Inman wants to find out the people who live in the district's opinion on how the high school is run. For his poll, he asks 10 people at the school board meeting. The population is the big group whose opinions we really want. Mr. Inman is interested in whose opinions? All the people who live in the district. So all the people who live in the district. So population, this is the who. Parameter is the what. What do we want to know about this population? What do we want to know about all the people who live in the district? Yes. Opinion on how the high school is run from all the people who live in the district. Sample. This is who we actually talk to. 10 people at the school board meeting. Statistic. This is what I was actually able to find out from my sample. What did they find out from their sample? Yeah, we got their opinions on how the high school is run. And then 2 more parts to this. Is this biased? Yes. Why? What'd you say? They only asked 10 people from the school board meeting. So potentially, whose opinions did they leave out? All the other people that weren't at the meeting. Remember, we're not going to have time to ask everybody in the district. So a sample is supposed to be like a snapshot of what the big group thinks. It's okay to not ask everybody. We have to trim that down because we don't have time. Can you think of a group of people that lives in the district whose opinions weren't represented by the 10 people at the school board meeting? Students' opinions weren't represented, most likely. Sometimes students will go to school board meetings, but not usually. Who else's opinions might have been left out? Teachers. Anybody else? Do you guys know when the school board meetings are held? They're usually held, at least here in Pike Township, they're held every other Thursday night starting at 7 p.m. If people that work the night shift have opinions about how the school is run, they're not ever going to be able to make it to a school board meeting. So they would never have a chance to have their opinions represented at the meeting. So what I'm going to put here for my justification, we think this is bias. Not everybody who lives in the district had an equal chance of being selected for this survey. If I don't get picked, but I had a fair shot at being picked, it's an unbiased survey because somebody who has the same opinion as me probably did get picked. If everybody's got an equal chance. So, oh, yes, it is bias. Not everyone who lives in the district had an equal chance of being selected for the survey. So I'm just going to give a real quick example here. People who work the night shift. No. But what you could do instead of remembering all of this wording right here is give an example of a group who wouldn't have had an opportunity to have their opinions represented.
So where it says
Justify your answers, say, you know, people who work night shifts didn't have the chance to have their opinions heard. You have to be again, this does not mean that everyone's opinion gets heard. When we do sampling, not everyone is going to be talked to. But if the sampling is not biased, everybody had an equal chance of being selected. And so you're going to get a much better idea of what the whole group looks like because everybody had a fair shot to be selected. Maybe you didn't get selected this time, but maybe you do get selected next time. Yes, ma'am. Number 11, absolutely. First 3 questions, please do not get intimidated by these. These are very straightforward and just as easy as they initially appear. How many options do we have for the first number? What does it tell me about the first number in this bike lock code? It's a 5, a 6, or a 7. So how many numbers do I have to choose from? 3 options. It's just 3. So right here, I'm just going to put a 3. What do we know about the second number in the code? It's not a 5, 6, or 7. So we have to exclude those 3 numbers. So if I knew how many total options there were, I could just minus 3 from that, and that would give me how many options there are for the second number. Yes. Thank you, sir. How many total options at the beginning do we have before we do any excluding? 50. There are 50 total options here. And so I would do 50 minus the 3 that it can't be, and I get 47 options. So I'm going to put 47 on this line. What do they tell us about the third number? It's even. When I write down a whole list of numbers, how do we find the even ones? Divided by 2. Where do those fall in the list? Is 1 even?
No.
Is 2 even?
Every second number.
Is every second number. Every other number is even.
Is it 24?
Close. 25. Every other number is even. So half of the numbers are even. Half of the numbers are odd. So how many options do we have? 25. So A, B, C is just asking you to look at each of the clues and tell me for that particular number, how many choices do I have? How many choices, how many choices? This is allowing me to put the bike lock code together. I've got to enter 3 numbers on this bike lock to get it to open. I know how many choices I have for the first number. I know how many choices I have for the second number. I know how many choices I have for the third number. So how do I find the total possible number of choices? Multiply them, yes. 3, 47, and 25, yes. For the first number, we had 3 options. For the second number, we had 47 options. For the third number, we had 25 options. I'm going to multiply those together. How many total bike lock codes are there? 3,525 total possible bike lock codes. My first guess is 62810. Hold up there. Does this guess match the criteria that I've been given? Yes, the first number has to be a 5, 6, or 7. Yep. The second number cannot be a 5, 6, or 7. Yep. And the last number has to be an even number. So it meets all those criteria. So what's the chance that I guessed it right on the first try? Yes. 1 over 3,525. I'm going to scoot that over a little bit. It's hard to read. All right. My next guess is 517.9. What's the chance that's the right one? 0. Why? Yeah, the first number meets the criteria. It's a 5, 6, or 7. Second number meets the criteria. It's not 5, 6, or 7. But the third number is supposed to be even. Not even just supposed to be, it must be even. So there is a 0 probability. Or the directions said you had to write it as a fraction. So 0 over 3525 would be another way to look at that one. I would take either one of those. 0, I would take that. Part F. If before my first guess, I remember that the first number is a 6, am I having to guess about the first number anymore? So how many possible options are there with this new information about that first number? What do I know the first number is? It's a 6. So I have one option for that first number. I know it's a 6. Does it tell me anything about the second number or the third number? So how many options do I have for the second number? I still have 47. Because these criteria are still in place, except I remembered the first number in this. I'm not having to guess about it anymore. I've got one choice, and I know it's right. How many options are there for the third number? 25. What do I want to do with the 1, the 47, the 25? Multiply those. What does that come out to be? 1,175. So what's the chance, if I know that the first number is a 6 and I make all the other numbers match those criteria, what's the chance that my first guess is right? 1 out of 1,175.
Why is the first number 1 and not 6?
Why is it 1 and not 6? If I tell you the first number is 6, how many options are there for that? How many choices are there? 1. we're writing down how many options there are, how many choices. I only have one possible number. It happens to be the number 6, but it's only one choice for that first digit. Does that make sense? Yes, ma'am. Yes, ma'am. What else did you guys want to see? 10? All right. Let's back it up one. We want to know if these events are independent. So the definition of independent, if the probability of event A times the probability of event B is equal to the probability of their intersection, the AND, then the events are independent. So I need to ask myself over here, with the numbers they gave me, does the probability of A times the probability of B equal the probability of the intersection of event A and B? Well, let's start substituting in. What do I know about event A? Yep. Its probability is 1 over 7. So here in the place of this, I'm going to put 1 over 7. What do I know about the probability of event B? 3 over 5. What do I want to do with those two fractions? Multiply them. How do we multiply fractions together? Straight across. So I have 1 times 3 on my numerator, which would be 3. In the denominator, I do 7 times 5, which is 75. 75, 35. Good grief. Sorry, guys. I saw the 7, I saw the 5, and I wrote those two numbers down. 3 over 35. Let's try that again. What do I know about the probability of A and B? It is 3 over 35. They are independent. Why? Came out to be the same thing, right? They are equal. So yes, they are independent events. Up above, it says to show your thinking and explain your reasoning. Well, here's me showing my thinking. And over here, when I wrote out the definition of independent events, this is explaining my reasoning. What else would you guys like to see? Number 8? Absolutely. Not until Amari's back. Number 8. A 6-sided die is rolled. What's the probability that it is not a 1 or a 6? What are the numbers on a 6-sided die? 1, 2, 3, 4, 5, and 6. And I want it to not be a 1 or a 6. So how many numbers would make me happy? 4 numbers out of how many total possibilities? 6. That's my answer. Do you guys want to do 9 while we're here?
I have a question.
Yes.
Is this like stuff like this gonna be like, is this almost like the test, like the same, like?
Everything that's on the test should be clearly covered somewhere in this review. There are fewer questions on the test than there are in the review.
How many questions are there?
Give me a minute and I'll look it up again. What else do you guys want to do? 9? All right. On 9, I have a 10-sided die. So what are the numbers on my 10-sided die? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If I want it to land on an even number, which of these are even numbers? So how many is that? Out of? That's your answer. Other answers that I would also accept here. If you said half of the numbers are even, so you had 1 over 2, I would accept that. For number 8, if you reduced that fraction and you wrote 2/3, I would still accept that as correct. You do not have to reduce your fractions with probabilities. What else do you guys want to see? Number 3? Absolutely. For this one, the directions very, 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 very clearly state you are to leave your answers as unreduced fractions. All of the numbers should be able to just be grabbed off the table. First one, I want to know the probability that someone is an 8th grader. So my fraction needs to have all the 8th graders in the numerator and the grand total in the denominator. How many 8th graders were surveyed? 250. Here's all 8th graders. So that's my numerator. What's my denominator? 900. So 250 over 900. Part B, almost the same, except I'm not looking at 8th graders anymore. I want the probability that strawberry is their favorite flavor. So my numerator is all strawberry. And the denominator is the grand total. Nope, not on this one. How many people total said strawberry was their favorite? 367. This is all strawberry. Out of? 900. The next one, we have this little line on it. What does the line mean? Given that. Or I know. So when we go to set up the fraction, whatever I know, whatever's on the bottom, I need all of that in my denominator. So all swirl in the denominator. In the numerator, I want the intersection of the two events, 6th grade and swirl. If I want all swirl in the denominator, what's that number going to be? 533. Here's all swirl. And then I need the intersection of swirl and 6th graders. How much? 212. For the next one, I have another given that here. What do I know this time? Yeah, this time what I know is the 8th grade. So in my denominator is all 8th grade. So what's my denominator going to be? 250. The numerator is strawberry intersecting with 8th grade. Yep, here's strawberry, here's 8th grade, so that intersection is 82. Yep. Yes, you may. Yep, right over there. You're welcome. Does it have to be non-graphing? Okay, you can use a yellow one if you want. 82. You're welcome. Last one. Do we have a given that on this one? No given that here. So what's my denominator going to be if I don't have a given that? Grand total, yes. And the numerator is going to be the intersection of 7th grade and swirl. So what will my denominator be? 900. And then I want to see where 7th grade and swirl intersect each other. 7th grade, swirl, 153. Yes.
So what is like union? Is that what's that again? Do we add some grade swirl and then subtract it?
Yeah. So if this had said probability of 7th union swirl, we would have to do all 7th plus all swirl minus 7th intersect swirl divided by the grand total. Good question. Yeah, when you see the union, the U, that's when you have to do it differently. What else would you guys like to see or talk about from the review? The answers are all on Canvas, yes. You have to navigate to today's date in modules, and then you have to click on the page that has today's date on it. Is there anything else that you guys wanted to look at? Number 5? Absolutely. A bag containing 6 cherry, 8 strawberry, and 9 grape flavored candies. So how many candies are there total? 23 total candies. You pick one candy, decide you don't like it, put it back, then pick another candy. What's the probability that you selected grape the first time and then you selected cherry the second time? What's the probability that we got grape? 9 out of 23. What did we do with that grape candy? We put it back. So what's the probability we get cherry then? 6 out of 23. What are we going to do with those probabilities? Multiply them. So I would have 54 over 26 times 26. Sorry, not 26, 23 times 23. $529. Can I leave my answer that way? This time they wanted it written as a decimal. The nearest thousandth is 3 decimal places. So we have to put it into the calculator. 54 divided by 529. 0.012. This is how they want you to give the answer back. On the test, if you don't know how many decimal places to go out, because it says something like thousandths or hundredths or tenths and you don't remember what that is, raise your hand. I'm more than happy to answer that question. I don't want to leave you guys guessing about how many decimal places I need. All right? I'll happily tell you. Did you guys want to look at anything else at all, anywhere on the review? No? All right. So as I mentioned earlier, the review is up, all of the solutions. If you go to modules, I still have people asking me about this. You have to go to the modules. You have to find today's date, May 11th. It's not in that list there. To get the solutions, you have to click where it says 511 Review for Module 10 Test. That will take you to this page. And all the way down at the bottom are the solutions.
I got a different answer for number 5.
Give me just a moment and I'll come look at it with you. Paper test review is due tomorrow when you guys come in to take the test. This review right here, the one that says 2023, that's how you can earn extra credit. The Module 10 test review 2023, every single question you get right on that is an extra point of extra credit.